Hello everybody, welcome back to my channel. In this video we will be continuing from the last video where we discussed strings and array algorithms. In this video we are going to continue with 3 more problems related to strings and array. What are those problems are? The first one is string compression. We will compress the size of a string. Second is matrix rotate, and third one is setting zeros in the matrix. If in the row and column, if any cell found 0. So if any cell has a 0, then corresponding column and row will be made to 0. Let's get started on this video. Before we start the video, I will urge you to subscribe and provide some your feedback in the below comment sections, and if you please press bell icon so you will be notified whenever I get the new content. So let's get started with the video. So this is the string compression algorithms. Here what we are going to do is that we have a strings, assuming a string will have only alphabets small a to z or capital A to Z, and wherever this characters is repeating, we will replace with the counts. So for example, A, B, B, C, 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 D, 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 this particular string will look like this one, A2, 3 to, it will look like A2, A3, B2, and likewise. So let's get started. Very first logic we are going to place with, we are going to start. So here in this logic we are going to use immutable string. We are going to use a string. So let's get started and we'll jump directly in the code. So let's start with first logic or algorithm. We call it compress bad because there are two reasons, or mainly one reasons here we can say is that we are using compress string as a immutable variable. So every time in here it assign the value, it is going to recreate the variable, and again, so it's a memory overhead, and every time the space is recreated. So it is kind of bad in the say. So here you can say that it is the O means O notation, it will be n plus k square, because every time you assign the variable it will recreate it, and from it will run that many time in the string. So this is a bad. Otherwise we are starting from first length, we have created consecutive count consecutive 0, and every time we start counting from 1, and if next character is lesser than the length and it is not equal to from the current character, then we will again reset the count consecutive, because that character is that character counting is finished, and then we will set this value then count consecutive count character plus consecutive count, and then we make count consecutive 0 again for the next character, and we'll keep doing until we reach to the end. So ultimately it is running for n time, but same time this piece of code is running multiple times, and it is causing the bad bad algorithm. So then let's move to next. It's a slightly better algorithm. In this algorithm, if you see, we just instead of immutable string, we are using string builder. So every time we will see only replacement that we are just adding that character, and then consecutive count, and then making count 0 again, and start and keep doing it. This is one method. And finally better method is that, because here the problem is that if string is bigger. If a small string, we are fine with that, because a string builder already starts with some limitation, some buffer. We start with some limitation, or we can say some limit. If a string is bigger, then initial start, and then it will, whenever it add new one, resize it, then again the process take more time. So in that case we'll go to third, which is much better. In this little slightly different. In this here we are counting compression. How many total after compression, how much will be the length. So same logic, the logic which we are running here, same logic we are running here to count the compression, and that way we'll know the length of the compressed string. And when we create the string builder object, we will create with the same size. So okay, here I am missing, so I will set final length. So that way we will create the string at that size which we required for compression, and we'll do the same logic as we did in the previous logic, and that's how we will implement this compression. This is the final output, this is the final logic. So this is how we implement the string compression with this logic. And so let's move for the next algorithm and next problem. Let's test this code, compression code, and this is our string, and when we run it, it will give us this value A22. Yeah, this is hidden behind it, but A2, it just gives A22 B1 C5 A3. This is the string is A2 B C5 and A3. So this is next algorithm. In this is a matrix rotation. So we have a matrix of n by n. It means width and length are same, so same row and column. So it may be 4 by 4, 3 by 3, 5 by 5. Any matrix we will rotate it, and assumption is it should be the same length and width will be same. So in this recording, in this algorithm, is that this is our 4 by 4 matrix, and when we rotate it, it should look like that. So let's get started. So this is a simple method we have created. It's just simple rotate, and we will pass it to matrix n by n. So very simple logic. In matrix length, if equal to 0, or if it is not matching with the length and width, then we return false, because we don't want to do this that rotation. So let's get started. Then we start with this logic. Then we start with the n by 2. So whatever length we have, length divided by 2, so layer will be 0, and up to will run up to half of the layer, and the first will be the layer 0. So if let's take an example of this matrix. So this is our values are, and we have a layer 0. When we start, it's a layer 0, and then we have first object 0, last object will be 3, and then we'll start with I equal to 0 means first variable from here, and then we'll keep doing this. Offset will be this will be by default 0, because 0 minus 0 0. So and then we'll do, this is our logic will be, so m0 0 1, so 1 will go into top, then first we'll move last one to here, then we'll move 16 to here, then we'll move 4 to this one, and then one which we stored in top field, we'll move it to here. Then next is, let's take another one. In the next when it comes to second loop, it will layer will still be 0, first will still be 0, but I equal to 1, then offset equal to 1, then it will start from the first row and second column. So it will start from here, so it means 9 will go to 2. So this, it will pick up 9 and put this into, to 2, and then this 15 will go into 9, and 8 will go to 15, and then 2 will go to 8. Okay, the next step, then we have a last, still three values are same, but I equal to 2, and then offset become 2. So this particular logic will apply, and we'll move, rotate this. We'll start with 3, so 5 will go to 3, and then 14 will go to 5, 12 will go to 15, and 3 will come to 12. This is how the first particular rotation is. So we have rotated this one, so it will become, this whole row is rotated. Now this is next left, so it means this particular is completed. It will go to layer 2 and layer equal 1, and this is only one time because layer less minus 2, so 4 minus 4 divided by 2, so layer is still below 2, below 2, I equal layer is equal to 1, and then we'll go to this offset 0, and in this process it is doing for this particular section. Let's take another column. So same thing, 10 will go to 6 will and 11 go to 10, 7 will go to 11, and 6 go to 7, and that's way we have a final string. So this is our rotation completed. This is how this complete logic is very straightforward. Only thing matter of understanding is this one. So in this example we are creating a matrix of 4 by 4, populating with these values, and then we are printing this value, and ultimately we are rotating this matrix and return whatever result we are getting, it's true, false, and matrix should be already rotated, so we are printing this matrix again. So here is the run, when we run it, so here our input matrix, and this is our output matrix. So it is, see, rotated 0 4 8 12, now it's 12 8 4 0, and 1 5 9 3 13 is 13 9 5 1. So this is our output of rotate matrix. This problem is called zero matrix. In the matrix of n on n by n matrix, if any cell has a value 0, then we will make then that cell and every cell in that row and column 0. It's very simple, and we have two different solutions for this one. Now approaches are two different approaches. One is with some buffer, or we can say some buffer variable, third variable, using third variable, and second is without third variable. So let's get started. Set 0. So this is our code. So here we are using external variable to track down in the first row if any first row and first column has any 0 or not. So we are going through first row and first column, and if that has a 0, then we will mark it true to keep the track that first row and first column is 0, has 0 or not, because if we do not track and as we come across any zeros, we will ultimately end up doing entire matrix 0. So this is which we don't want. So for starting with the row and column, if it is 0 or not, tracking it. Now start for the rest of the matrix. If then we'll check if first row okay, then we'll start with each row. For each row, if we see any 0, if row is I equal to true, then we'll mark entire row 0, then entire, if any column is 0, entire row is 0, and then ultimately this nullify row and column is just a main method we are using here. So this is using a buffer variable. Sorry, where was buffer variable. But if you don't want to use buffer, then this is another logic. So row and columns, we checking is if any row and column has 0 or not. So same logic for each row will run that. This is if row has 0, then break. If column has 0, then we'll break and we'll set the values, means column and row has zeros, and then we'll start run for each rest of the string, rest of the matrix except the first row and first column. Will check if there is 0 or not. So we will check if matrix this row has 0, then we'll call first row 0 and first column is a 0. First column and will make the row 0, and first will make 0. Okay, if we'll check in rest of the column is 0, then corresponding row first element of the row and the column will mark it 0, and will same thing. Now we'll start nullify based on the value in the first column. So we'll run first in the first column. If matrix has is 0, then we'll make entire column, entire row 0, and similarly for each column will run. If any column has a 0, then we'll make every column 0, because we have identified here that if any row, if any cell has 0, then the corresponding column first element and first element of row and column should be mark it 0, and that's where this logic will come into picture, and it will run 0, and then finally we'll check if row has 0 and column has 0, then we'll mark entire row and column 0, and that will run into response. So let's run this application. Row a matrix of 3 by 4, populating with some values. The first row first column is 0, and then second row or maybe second column will be also 0. So we'll print it first, we'll print the value, and then when we run the matrix, then set 0, then it should print the 0. So let's run the code here. If you see an example, this is our input, first row 0, so it means this row, this column as well as this second column should be 0, and this is what we are expecting here. So this is that's where I'm ending up. So I'm ending up all string and array algorithms here in this video, and in the next video I will go with linked list related algorithms and problems, and please join my channel and see on my channel and stay tuned for the next video. Thank you for watching and see you next time.